So just like 8.3 was almost identical to 8.2, 9.2 is going to be almost identical to 9.1. So the only difference that you can see right here is now we're going to have to use our t-score or our t-chart. So again, the way you know the difference is if it says population standard deviation or population variance, you have to use the z-chart. If it doesn't say population, you're going to use the t-chart because we'll know our sample data instead. Sorry about that. Okay, so S is your sample standard deviation. S squared is your sample variance. So if they give you the variance, you do not square it. If they give you the standard deviation, you do have to square it. Okay? Remember, on your t-chart, we need to use what are called degrees of freedom. This is going to be the smaller of n1 minus 1 or n2 minus 1. So you're going to have two sample sizes. Sometimes they're the same. That makes it easy. If they're not the same, then you're going to take one away from your smaller one, and that will be your degrees of freedom. All right, so same 5 steps that we did in 9.2, only for step 3, you're going to have a t-score instead of a z-score. For step 2, you're going to have to use your t-chart. Okay, this is the exact same as down here. Again, confidence interval, just have to use our t-chart rather than our z-chart. Same thing with degrees of freedom. Okay, so those two are the exact same. So here we go. The average size of a farm in Indiana County, Pennsylvania is 191 acres. Average size in Greene County is 199. I actually met a couple here from Pennsylvania, so that's pretty cool. Assume the data were obtained from 2 samples with standard deviations of 38 and 12. So notice it does not say population. That's why we need to do the t-chart. Sample sizes are 8 and 10. Can it be concluded at alpha equals 0.05 that the average size of farms in the 2 counties is different? Assume that it's normally distributed. So that assumption is just so we can do the problem. Again, you'll always be able to do the problem. So step 1, H sub 0 is going to be mu1 equals mu2. H sub 1, it doesn't give us less than or greater than, so it's just not equal to. And it says, can we conclude they're different? So this one is going to be the claim. Step 2. Not equal to means it's a two-tailed chart, or two-tailed test. Your degrees of freedom, so our sample sizes are 8 and 10. 8 is smaller, so then we take one away. So your degrees of freedom is going to be 7. So we're going to go look up here. We need the 2 tails at 0.05. Remember, we don't cut it in half. 2 tails, 0.05 down to 7, 2.365. Which also means negative 2.365. Step 3, t equals rather than z equals. We have 191 minus 199. Again, technically minus 0, but you don't need to write that, over square root of 8 squared over, oh no, sorry, standard deviation is 38 squared over 8 plus 12 squared over 10. So since this is a not equal to, it technically doesn't matter what order you put them in. Most people will actually flip those two around so they don't get a negative number, but it does not matter either way. Okay, so not equal to, it doesn't matter what order you subtract these in. You should get negative 0.57 if you do it that way, or if you flipped them around, you would get positive 0.57. So that is going to be over here. So step 4 is going to be do not reject H sub 0. So we're not rejecting, meaning this one is true, but we always have to talk about the claim in step 5. So we would say there is not enough information or evidence. to support the claim or conclude. If you want to use the word conclude, that's fine. Just do not use the word prove. If you say prove, it's going to be counted wrong because we're not proving anything. We're just making a statement based off of our very limited data of 8 farms and 10 farms. Okay, so there is enough evidence to support the claim that the mean farm sizes are different. Okay, so just like in 9.1 then, once we do that, we can also look at a confidence interval. Now, you don't have to do both of them together, all right? So you should be able to do a confidence interval without having to do the 5-step problem. So you can always do the 5-step problem just to make sure. If you're not sure about the confidence interval one, you don't feel very certain about it, then you can always do the 5-step problem. But if it doesn't ask you to do a hypothesis test, okay, if all it asks for is a confidence interval, then you do not have to do the 5-step test, but you always can to make sure. That's up to you. So it says to find the 95% confidence interval for the above data. So again, we're going to do 191 minus 199. Some people, again, would flip that. I'm going to do the plus minus thing instead. So just a reminder of how to read this chart. 95% up to 7. It should be our same number because it's 95% and 0.05 up here. So that's why it's the same. 2.365 square root of 38 squared over 8 plus 12 squared over 10. So we would have negative 41 is less than mu1 minus mu2, which is less than 25. So you can be 95% confident that the difference of the mean farm size is between negative 41 and 25 acres. So obviously those aren't the means, that's the difference of the means. So again, what this says is if you could take every single farm in Indiana County and calculate the mean, and then every single farm in Greene County and calculate the mean, and subtract those two numbers, that difference, what you get when you subtract, should be between negative 41 and positive 25. Obviously that's a huge range, but that's what it gives us. So this one's different than from 9.1. 9.1 did not have one positive and one negative. So what this means is that 0 is somewhere in here, right? If it goes from negative to positive, that means 0 is in here. If 0 is in your interval, that means these two could possibly be the same. Or basically, we can't say that they're different. So this one would say since 0 is in the interval, you cannot conclude that the average farm sizes are different. And that's exactly the same conclusion we got up in our 5-step problem. Okay, it said do not reject, therefore there wasn't enough evidence to claim that they're different. So same thing, since 0 is in here, that means we can't say they're different, because if you subtract two numbers and get 0, that means they're equal to each other. It doesn't mean they have to be exactly equal, but just with the information we have, we can't conclude that they're different. Okay, I think I'll do the last couple on a different video to make sure we don't run out of time.